Today we're going to be talking about volume and surface area of rectangular prisms, what the formulas are, and where they came from. So this is still part of our geometry unit, and our color for the geometry unit is yellow. Alright, so we're going to talk first about the volume of rectangular prisms. If you guys have ever seen graham crackers, we know that they are in the shape of a rectangle. Okay. Rectangular prisms, they have a base that is the shape of the rectangle. So this is the base of a rectangular prism. It's one graham cracker. The dimensions of a graham cracker are 5 inches by 2.5 inches. So we're first going to calculate the area. Remember from yesterday that our area for a graham cracker is length times width. So our area is going to be, again, length times width. So in this case, our length is 5. And our width is 2.5, and that means our area is going to be 12.5 inches squared. So now we've talked about one graham cracker. Let's consider a stack of graham crackers. What is its shape? Well, here's your stack. It's no longer a one-dimensional shape. It is a two-dimensional shape. It is a three-dimensional shape. That makes this a rectangular prism. The height of the stack of graham crackers is approximately 2 inches. Using this, along with what we know about the area of one cracker, how could we find the volume of the stack? So we know that the area of the base, this part of your graham cracker stack, the one graham cracker, okay, has an area of 12.5 inches squared. So we can take that area of the base, the single graham cracker, and we can now multiply it by the height. So our volume is going to be area times the height, or 12.5 times the height, which is 2. And 12.5 times 2 gives us 25 inches cubed. Volume is measured in inches cubed. So the formula for the volume of a rectangular prism, V is equal to, we already said it's the area times the height, but we know that area is equal to length times width, so we can replace area with length times width and then times height. So our formula altogether is area equals length times width times height. All right, we've got two examples here. They're asking us to find the volume of each rectangular prism and to show our thinking. So this is a three-step process. The first thing we need to do is write the formula. So volume equals length times width times height. So our volume is going to be the length of 6, a width of 3, and a height of 2. So if we multiply those three numbers together, 6 times 3 times 2, we have a volume of 72 feet cubed. So step 2 is to plug in, and step 3 is to write your final answer, including units. All right, second example, we have another rectangular prism. So volume is equal to length times width times height. The first step is we write the formula. Step 2 is to plug in. So we have a length of 11, a width of 5, and a height of 6. So then we would multiply 11 times 5 times 6, and we get a volume of 330 feet cubed. So again, 3 steps. Write your formula, show your plug-in, use your calculator to find your final answer. All right, we're going to next talk about the surface area of rectangular prisms. So we're going to knock out all the rectangular prism stuff today. And this is still part of the geometry unit, so we're still looking at our color coding of yellow. Now we're going to take the graham cracker box. What is its shape? Well, it's a three-dimensional shape, and again, it's a rectangular prism. All right, list the rectangles that make up the box. Well, we have the top and the bottom. We have the left side and the right side. I'm going to use L for left and R for right. So we have the top, the bottom, the left side, the right side, and then we have the front and the back. Okay? Are there any rectangles that are congruent? The answer is yes. And which pairs are congruent? Well, the top and the bottom are going to be the same. The left side and the right side are going to be the same. And the top and, the front and the back are going to be the same. Remember, congruent means they're the same shape and the same size. Okay? Draw one rectangle from each pair below and include the dimensions. So if I look at the top and the bottom, I notice this is going to be probably the longest rectangle, and it's also pretty skinny, the top and the bottom. And we include the dimensions. So if I look at the top and the bottom, it has a width of 5.2, and then it has a length of 10.5. So we're kind of dissecting this box. We're taking it apart in our minds. Okay, the left side and the right side we know are tall and skinny rectangles. So this is the left and the right. Okay, they have a height of 8 and a width of 5.2. Again, we're dissecting this in our brains here. And then we have the front and the back. This is the largest rectangle, and it's also the fattest rectangle. So it looks something like this. That's the front and back. Okay, and the dimensions for the front, it's 10.5 across the bottom, and it's 8 up the side. How could you find the area of these rectangles? Well, we know that the area is the length times the width. So that's our formula from our formula sheet. Find the area of each rectangle you drew above. So for the first one, we have 5.2 times 10. And that gives us 52 inches squared. All right, the second one, we have 8 times 5.2. And that gives us an area of 41.6 inches squared. And for the last one, we have an area of 8 times 10.5, or 84 inches squared. So those are our 3 areas. Okay. And how could you find the total surface area of the box? Well, we could add all of these together. So notice we have 2 that are the top and the bottom, so we would have 2 times 52. We have 2, the left and right, that have an area of 41.6. And we have 2 that have an area of 84. Okay. So we're going to add all of this together. We have 2 times 52, that gives us 104, plus 41.6 times 2, and that's 83.2. And we have 2 times 84, which gives us 168. So we have 104 plus 83.2 plus 168 for a grand total of 355.2, and surface area is measured in inches squared. So if we look at our formula here, we have 2 length times width plus 2 length times height, plus 2 width times height. Okay, so there's your formula. We have 2 more examples and then we're all done. So this is the 2 same rectangular prisms as on your previous page, and we're just going to find their surface areas now. The first step we do is we copy the formula. Surface area is equal to 2 length width plus 2 length height plus 2 width height. So we're going to plug in. That's our second step. Surface area is equal to 2 length, and it's always a good idea to label, is going to be 6, and your width is going to be 3, plus 2 times the length of 6 times the height of 2, plus 2 times the width of 3 times the height of 2. For this one, I would suggest doing a 4th step where you actually do all the multiplication and then doing all the addition. Otherwise, it's very difficult to keep your order of operations straight. So surface area, we have 2 times 6 times 3, and that gives us 36, plus 2 times 6 times 2 gives us 24, and 2 times 3 times 2 gives us 12. And then we're going to add all of these together, 36 plus 24 plus 12, and we get a surface area of 72 feet squared. Second example, pretty similar. We're going to start by writing our formula. Surface area equals 2 length width plus 2 length height plus 2 width height. And then our next step is we're going to plug in. Okay, so we have a length of 11, so that gives us 2 times 11. We have a width of 5 plus 2 times that length of 11 and a height of 6 plus 2 times a width of 5 and a height of 6. Do your multiplication step. So 2 times 11 times 5 gives us 110 plus 2 times 11 times 6 is 132 plus 2 times 5 times 6 gives us 60. Add those three numbers together. I have 110 plus 132 plus 60. For my final answer, surface area is equal to 302 centimeters